Good afternoon, everyone.
Hello.
I am Dr. A.K. Sood from National Institute of Foundry and Forge Technology. I welcome you all in this presentation, which is which will be delivered by Professor P.K. Mishra on the area of introduction to non-conventional manufacturing technology. Professor Mishra does not require any introduction. We all know his contribution in this area. He has developed so many machines, and he has written one of the wonderful book in this area. But since as a formality, I will introduce him to you all. After graduation in mechanical engineering at the Regional Engineering College, presently which is known as NIT Rourkela, in 1996, Professor Mishra has worked in various universities and institutes of repute. Presently, he is visiting professor, School of Mechanical Science, IIT Bhubaneswar. His main interest is to develop new process and propagate the knowledge throughout India. His research areas include non-conventional manufacturing, mainly thermal processing of materials, spark erosion, laser processing, micro manufacturing, rapid prototyping, and microsystem technologies there. Sir, we are very honored that you accepted our invitation and agreed to deliver a lecture on this very beautiful topic of unconventional manufacturing processes. Sir, I welcome you, and from you here you can continue your presentation, sir. Thank you very much.
Okay, thank you. Could I start?
Yes, sir.
Okay, I'll be talking on non-traditional manufacturing, but it is a non-conventional manufacturing technology. Though the name is slightly changed because I've used British style, non-conventional, but however, American style is non-traditional or non-traditional. In this called unconventional because which is not conventional in industries, but any time it becomes a process. Now, my aim is completely everything. Always it will remain in non-conventional. That I'll come to the end. Okay. Now, my mindset is with Mahatma Gandhi. He has told a thing: an ounce of practice is valued more than tons of preaching. So as a teacher, we go on speaking without doing anything at all. Our course curriculum is such a way we talk high-fi, but we do practically we have done nothing. Even a Chinese made what you call toy, simple clips are sold in India. So I will start this thing how things are changing, how the machines are developed, and in course of that one, I will take the process because I started with unconventional machining. Now we have changed to what you call changed to uh, uh, this one. Now, whenever let me do, Professor Ghosh has elaborated, told everything, and in the process of Professor Joshi or Professor Dikshit might have told you something, but I will try to take you the design and manufacturing both closely together, because you can design anything, but you cannot manufacture it. And when you manufacture it, there will be a problem in the mistake in the function. Now I start with, because when you see the manufacturing process, we start with the materials. And the materials depend, when we choose a material for any use, we see what is the environmental conditions, such as stress, strain, temperature, corrosion, etc. So many things are there. then when we talk about shaping the shape, depends on how the application, the shape will be designed according to that size, because combined with material, shape and size will shape and strength. Size will depend on the shape and the strength, because that is the way how we have to proceed. Now, then coming to the accuracy, because in mechanical engineering, accuracy of thing is the most, none other engineering, they talk about the accuracy, but mechanical talks about accuracy of the process, everything. And that's what we call what precision. If bullet is moving and hitting the target or anything which does is depends on the accuracy. Then we talk about the finish. These are two things. Performance, because the friction will depend on the performance, the friction, as what you call aesthetic values. Aesthetic values are different, but main thing the performance, because we have something like a ley lines. We have got ley lines. When we have got the ley lines and both the ley lines will match together, and if you have got anything changes, the friction will vary from 0 to maximum, because you see the ley lines should be there. If I take my fingers and it goes up and down, and then you will see if it moves in this direction, same direction, then you will see the friction is minimum, and if it goes in this direction is the maximum friction. So the losses in the system changes, performance changes. Then last thing which we never touch, what is the surface integrity? How far the surface, because always the surface interacts with another surface. Now, the surface integrity is a very important factor. That's why we have got another thing which has to be seen, that surface integrity is to be maintained so that the surface will be in coherence with the substance. Okay, and it detects the reliability of the component, because if there is a surface failure, the whole function is lost, accuracy is lost. Now we have to see how far the surface is in coherence with the subsurface so that the performance is better, reliability is more. Now coming to, let's talk about the confidence technology. Professor Ghosh has elaborately told it, but I'll take a simple thing. I take the two materials are either brittle or ductile. Now, if a ductile material we have got stress and curve, we have a stress and curve. For ductile material we have got this one. For a brittle material we have got zone is very, plastic zone is very less. So here we have a wider zone. For ductile materials we can have three processes, because this is a zone where it is a design process where there will be no failure. Okay, after this one there is a failure, we can move this one plastic zone. So if a ductile material can be processed in the plastic zone, then we call it forming. Then after the failure, then we call that one is missing. Similarly for this one, since the plastic zone is very small, then we can go for meshing directly. But however, process and even plastic materials, the brittle materials can be plasticized depending on the giving a high compressive force and changing the temperature. However, when we talk about the machining process, we are always in the failure, about the failure zone. Now, that's why what we have got, we have got a raw material, we process to a finished product, and we have got so many process because manufacturing processes are different depending on the accuracy of the thing. Casting accuracy is lowest and goes, and finally, so we have got three sets of parallel processing of the components, and when they are assembled, what you call together to give a finished product. This is the older ways of manufacturing. So the sequence, there are different sequences are there. So what we see, we have to process depending on the strength of the material. Now let's say the material is developed depending on the years and depending on the requirement. We said first the engineering materials, what we use is the aluminum, which can, because softness, we can process that one by any means. Okay. And then we have got, you see the changes, because 1925, the Wright brothers, when they started, the first was a failure when they used aluminum because of the lightness. Now, then it was success only when aluminum was changed to durable. So it's improved strength and the system survived. And then gradually as the year, you see use of titanium came in, because the rocketry and it has not started that time, but that was in conception. Gradually it increased. By 65, you see it's just a high strength temperature resisting materials when we wanted to increase the speed of this thing, and there is a high temperature thing, because with temperature the things, what you call, the elasticity, everything, curves, test and curve changes everything. Now, when we manufacture, Professor Ghosh has already told this thing. Just and then we have got thing. We have got Wilkinson's boring machine, because we have to have a piston and cylinder to match to. He was telling yesterday. Then finally we see 12 screw cutting machine came in, because the fastening technique has to be changed. Then with this milling machine, mass production technique, milling machine can give a better accuracy. And pitch turret lathe, because multi-drilling operation, when we do different operations, we go for pitch turret lathe. And then to question came how to measure the accuracy. When in Wilkinson's boring machine time, the difference between the piston and cylinder was measured by a ceiling. Thickness of ceiling, that is about 1/8 of an inch. That was the thing. Then it didn't function. So milling machines came in, and gradually it increased, and we used micrometers, indicators, then gradually. So accuracy by measurement changes, and drastically when electronics are blended to this thing, then we proceed in a very thing. Now, Professor Ghosh has already told, we are already gone to how to measure an atom itself. So what you can see here. Now, there is another thing, when it started coming, the days are changing. Days are changing because the miniaturization of the job, because when you want to go for higher speed, the force has to be reduced. So mass into the acceleration. If the mass is less, we can accelerate much more faster. That means the thing has to be smaller and it's portable. Then only you can think of this thing for general use. That generally most of the consumer products, these are the things, domestic applications such as refrigerator, microwave oven, and all this, because you see these are utility items, consumable items, and by the consumer products, and then come to the mobility, automobiles, high-speed train, aircrafts, and then comes the computer, all these things, satellite. Yesterday was telling you computer machine, all this being used by each individual. Then the quantity production and the smallest size miniaturization is very much required, because there is another contradicting this thing. Population growth is more, and it is people's requirement is different. and declining natural resources as creating problems. Because gradually, if you consume the Mother Earth, I'm sorry to say here, we have country is selling the raw materials outside, and we are buying the finished component. And you see, we don't have to manufacture a good quality steel even. This is a pathetic situation. We're selling so many Mother Earth and selling outside, and we're creating nothing. And then the components are becoming much more complex, because to make it very smaller size, complex shape is changing, because you are changing the materials, and many more other factors are also involved to solve the problem. Now you can see here, the component is, you can see the gear size, this is an ant size, and this is about 200 micron gears to manufacture. You can see here a mechanism. This is used in when the surgeons, they do the operation, and we have to grip the what you call all the veins and all these things. This is a gripper which is to manufacture. You can see this is about 400 microns. Okay, and sometimes it's bigger. You can, depending on the size, you can do it, and what you call. Then you can see this is a 200 micron wheel, but to drive this on, we can't use a motor and all these things, excepting what you call, Professor Ghosh yes, told, we have to go static motors and all these things. But now, static motors are all right, but it cannot give forces unless you have a mechanism. And these mechanisms are completely different than what is to be used in a bigger machines. Now you can see, I will give you a small example. When the object size is changing, you can see there is a square hole, 45 by 45, and up to a depth of 50. Now the corner will be around, depending on the cutter what you are using, because you have to use a small cutter, and the corner radius will not be less than the radius of the what you call cutter. Now, similarly, if the size is changing and depth is more, and it's a finish, you see that it is open tolerance. Now, here when I put a tolerance, then problems are still becoming more stringent. So, coming to small hole in a hard material. Now, in all the things you can see, with a die block is to be manufactured. You go on machining 3D, what you call milling cutter, and then it becomes ley lines are there, all these things. Then you will see the flow lines on the surface changing. Now coming to another one, the piston cylinder. We have got a piston, and we have got a piston and cylinder. We have got a gas and pin. Now it reciprocates, and the force comes on the both the sides of the piston, because when the piston crank rotates, the piston force come on the side perpendicular to the gas and pin direction. Now you will say wear and tear, because normal stress increases, wear and tear increases. Thereby, then will be piston slap will be there, and knocking will be there. So many things there. Now another one thing, the friction increases on the both sides, because when we manufacture by boring process, the ley lines are so difficult. Then we do what you call hone the surface. We move this one in a vertical downward direction. Finally, what happens? The piston while coming down, it will move along the ley lines, because when the movement will take place, it will take the minimum friction action. So it will take the ley line position, so it will go on vibrating, and gradually you'll see it. That is why sometimes we see the engine is machine after buying, we have to put the governor and check the speed. We will not allow That one. But nowadays they run it, make it smooth and all these things. But nowadays we can use the ley lines in the vertical direction, so that those are linked and many performance increases. Now, so we have to have so many processes in the conventional technology. So we have got a raw material and finally it goes to a finished product. Now we have got process one, basically one deck, with process two and so on. We have got enough processes, even sometimes we have got heat treatment and all these cycles are each one is to be done. And finally we have got a product, and there is a fight between the production manager as well as the worker, that you have made spoiled the thing. And finally what happens, all this process I got two factors: processing time and we have got handling time. Now there are two factors, that means processing number of processes, if we increase the processing time, is cycle time is more, or you have a number of processes increase this one, then the production loss is there. That means we have got now two problems will arise. Now it is, I have given a small cartoon that these are manufacturing. If we don't plan the manufacturing processes in a right way, then there will be a fight between the what do you call, the line thing and the fight between the other one. Both the lines will not match. Okay, so these are manufacturing processes unless we satisfy its conditions. Now, the basic problem, what you see, we have got two things: automation and the process technology. If we decrease the processes and you decrease the number of components, the processing time becomes much more smaller. Or if you combine many processes to something, then the automation problem is much more solved. So main problem is that one. Let's try to see how we can change the process technology so that the automation problem is also satisfied in a better way, and we produce the manufacturing the component in a nice way. Now I'll show you before that thing. See how the technology changes. I'm giving an example of what you call Tata Nano. You can see. Now, you have seen the process of manufacturing a product, how much involvement of different machineries are required. And that this is one of the modern factory where we take the advantage of the robots and all these things for the assembly and all this. Anyway, let's look at the problem. This is not only the one industry, there's so many industries are there. Many things in advanced manufacturing maintain productivity with increased strength and work of the work material. That's gradually everybody wants a harder and harder material. And that means the tooling has to be much more harder than the work material. Otherwise, we cannot produce it. Then sustain productivity with desired accuracy, shape, and surface integrity and work materials. And on the work material. Now improve the capability of automation systems and increase just their sophistications, because then it is become, when we work on the automation systems, it is becoming much more costlier. Then because there are so many motions are there. Now, if you can reduce a 3D motions to a single degree or 2 degree motion, then you see automation problem can be solved. So these are some things which are to be seen when you try to go for a manufacturing process and build. Now, how can we solve it? Now, thing is that the most startling advances have their origin at the boundaries of the specialty, where the techniques developed in one of the field are applied with a fertile effect to the subject matter of another. If the cross-fertilization dwindles, the rate of scientific advancement will also surely dwindle as well as. And so anything that encourages cross-fertilization is all to be good, said the philosopher Isaac Asimov. And this means that we have a different science, and we will forget one science, then we neglect the other science, then the cross-fertilization will be done. Now, that is the philosophy with which the unconventional technology has been manufactured. I'm trying to tell, in the conventional process, what you see, we have got a cutting tool. I make a surface because the compressive force at the tip of the tool is much higher, so that that compressive force makes a shear plate. Material is sheared here, but material is sheared, and then see some energy goes away with the chip and some with the work that hits the material. So this technology, instead of this thing, can we go for unconventional? That means take a beam of light, because hardness is a problem. The tool has to be harder. Now, instead of this thing, make this material any material and put an energetic beam onto that one, convert the beam onto the surface. That means take a material which is weaker in one side. Here I want to tell you one thing. When we play football, okay, or badminton, let's take the example of badminton, everybody has seen. We see my opponent is weak in the backhand. So I'll put all the onto the right court, so that I'm taking the weak point of the opponent and I'm taking the advantage over his weak point and attacking that. Similarly, we do in football also. So that means a material which has got some weakness for some energy will apply that energy and try to do it. Because now, instead of going for a classic tool, we can take a energy beam and try to solve the problem. That is what is called unconventional way of manufacturing. Now, let's say raw material is there. Now here, if you try to solve this problem, becomes much more difficult to answer by mechanistic approach. So what we can see, we take a raw material and that is to be turned to a finished product. Finished product. So what you can see, you can apply mechanical energy. We fail. Suppose we can take the same mechanical energy in different form. Then if you take electrical energy, if the material is weak for electrical energy, use that one. Chemical energy, if it is weak for chemical energy, use that one. So similarly, so many energies are there that can be applied depending on the weakness of the material to the energy level, so that we can deform that one in a mathematical way. So in this thing, we can take a mechanistic approach. We can see the deformation energy, some constant, and energy to the power n. N is the, you see, and t is the time of interaction. The interaction time will give the total deformation energy right side, and that amount of energy if you give, the material will be. And so so many processes are there. Now generally what Professor Ghosh has told, forming, joining, measuring and all these things, then we have got GPM, and unconventional is one of the sources. Now, my idea is telling, I'm trying to tell this one, we'll not only concentrate on the unconventional sources, but we will try to extend this one to cover the entire. Wherever back, or that we can extend the unconventional forming machine, and I will show you that we have developed such type of things, and it's possible in the country, and we can say many people must have done it, but I have never seen in India people that do like this. When they started, you see, there's so many processes are there, which is considered they do it. One is called ultrasonic, what is it cutting, where ultrasonic is the impact you give and try to machine the materials, because the impacting energy produces a higher stress than the static forces. And then we have got particle in motion. These are mechanical stresses that already Professor Ghosh has already told. Chemical processing, we put a mask and there is an opening and this is exposed. I can tell you one thing, that whenever we want to apply something, we put a mask and apply very precisely onto a point, so that reacts, cauterization process in medical science. So similarly, what you can see here, the electrical energy, instead of this thing, if it is an electrolyte, instead of chemical, we can take an electrolyte and apply some electricity, various what do you call, chemical synthesis, and obeying Faraday's laws, then we can machine that one. We call that one electrochemical energy. And then we have got electro discharge measuring, produce a discharge, and try to do it. Now you might have seen these are minute light links, which can create a high thermal stress and then try to vaporize or melt the materials. We can use a laser beam and focus that one onto a target, and we can do whatever we like. We'll discuss in the future. Now then we have got electron beam technology, where you accelerate the electron beam and try to do it. And these are ion beam processes where the mass is, because here we require vacuum. Now when you go for ion beam, we can work in a moderate process, because vacuum is a big problem, because some of the things with degases, those cannot be processed with this one. So we go for ion beam processing. Finally, we have got another one thing, is the plasma beam processing. These are the standard things which are gone unconventional, but now it has gone to conventional. Now we will see that how we are trying to manage each one, try to develop newer technology. Now, yesterday, Professor Ghosh has told the completely what you call processes. We have got all these processes and all these things. So now we can see each energy, when you see, it has just side effects. Any process. Now, we have got a positive, some process side effects are bad, some side effects are good. Now, other one thing similarly are will produce another type of process. So each energy will produce different types of characters on the surface. Now, we want a character A. Let's say measuring process gives a character A. And other things you can see, chemical process will give another type of what do you call surface property. And similarly, each one, since they are using different types of stresses, okay, so they will produce some side effects which will nullify the other one. Or we will see one is negative characters, and the new process has got a effect which will nullify that one and give another character. So similarly, what we can see, because these are sub remotely given, but telepathy is given, and this is physical contact, so that this can be applied. Even if you are working with this one, you can work this one. Similarly, you can develop hybrid processes which will give the actual characters on the surface. Anyway, we'll discuss further when going to this one. So we have got so many processes, mechanical processes, we have got atmospheric and all these things. Because the red ones I'm trying to cover, other one is just modification. This one I will summarize because we cannot deal. We cannot deal further. So we can see that the electropolishing and all these things are coming electric thing. Red ones I will touch down, and other processes will I show through videos and all these things, and we'll. Now, to hybrid processing means we can bring in A, B, C character. So we'll take which character A is I'm getting one process, B character is another process, C character another. We can hybridize A, B, so we get a B character. Similarly, we have got any permutation combination, we can finish a product in no time. No time, time is short because everything is processed in months. That means we are going to a concept of unit-head machines which can manufacture a particular typical type of component with all the surface characters matching with the design. Now, here is the abrasive jet machining process, and where abrasive particles flows through a nozzle. This is a mixing chamber where air gets mixed with the particles, and this is the inclined flow, and then you see vertical impact and inclined impact has got two different effects. Ductile metals are to be cut by vertical inclined process, and brittle metals are to be cut by what you call vertical systems. And these are the machines which are reported abrasive jet machining. It costs near about 10 lakhs, but in IIT Kharagpur we have downloaded a few thousand rupees. And here we can have got all the variables because this is fixed variable, everything is constant. Here we can change anything, see the how it reacts to them. So things what you do in an educational institute, you have to develop a smaller setup. That's a technique. Raw material is very costly. We have to work with different materials, and variables have to be addressed. So similarly, we have to design. This is the machine which we designed in Kharagpur 84. Now, similarly, this abrasive machine, you can see, you can run some small scale industries, tumblers. You put a sticker on the surface with stencils cut in it and give an impact, vertical impact. You'll see glass being a metal material, it will machine out, whereas for vertical impact on what you call a soft material is not possible. This stencil is there. You put this one, cut the glass. Similarly, any that is mask this one try to do it. And similarly, thin nozzles. When you make the wafers, silicon wafers, tungsten disc, we have to sample the sides because it will fail, because these are brittle materials. So you can use a jet and try to build the material. Now coming to the ultrasonic machining, you have got a vibrating tool, and we have got some abrasive particles in a slurry, and we vibrate this one, try to machine this one, because the vibration will cause a damage, because on the work material side, a brittle material, and tool is a softer material, so your entire vertical impact will be less, so that you take any step and try to give the impact and try to machine the materials. Anyway, so far the design is concerned, in 74, we couldn't import, because there is a big story we felt that is ultrasonic machining. It was developed in Jadavpur University, and it is just like a drilling machine, and it is transducer is used. This is the transducer, and then is a nozzle, a flow nozzle is there, the flow nozzle, and we developed this one. The electronic circuit, how to use this one, we developed there. Now coming to IIT Kharagpur, we developed that this is smaller watt and this is a higher watt. But another advantage, what we observe in this machine, because when you work in the research lab, you see, you take every aspect of the machine or performance of the machine, take your heart. You think of a new process. Now similarly, what you call a bigger system which can work between 15 kilohertz to 100 kilohertz, you can process many things. You can weld it, everything, you can do it. That was developed. Anyway, let's see how the ultrasonic machine works. This is a silent movie, and we have got episode, sorry, and this vibrates. So there is a constant impact through the average particles, and we now with ultrasonic machine, you can manufacture many important components, small, irrespective of size and shape, you can manufacture, and you can see a delicate carbon grid heater for nuclear reactors can be manufactured this one, because it is sensible. You can write also, make a embroidery on the what you call Excel. You can do it with this type of. Now there is another thing, chemical wasting process, which gives a stress-free, crack-free surface. Now this is a very easy technique, and everybody should do this one, because when you make a model, you can don't want this one. You take any component and mask that one depending on the thing. Pass this one, keep opening, and we take a etchant and try to and control the environment with a heater, and the etching process will proceed, and that is a chemical meshing process. Now here you can see we take a material, clean the material and put a photoresist, and then we put a negative to transfer the image onto the photos, then develop that one. After developing, then you etch it and finally strip it, remove the mask, and then we get the finished product. So many components, all the meshes, fine meshes, and all these things are manufactured, and difficult component also can be manufactured with this one, which is the simplest and easiest technology. But you can develop, do this thing. Machine is not required. An experiment you can try with the thing with tablet, so you can do this thing. And then let's see. Now, these are some components. This is a thing, say PCBs, printed circuit boards, copper clad board, and then we put the mask depending on the what you call the line networking is required. Then we etch it. This is a PCB board we will have to manufacture in this chemical etching process. And this is a machine satellite dome. Spherical domes is very costly material, and you can see these are to manufacture. You can see there are some squares are there, small squares. Those are the solar cells are to be put in so that the energy can be um, uh, generated for the satellite itself. And then coming to the electrical process, it is very much the property is same as what you call CSM process, stress-free, crack-free, which is a very important factor in the bending strength of the material. Now, this is a same process where the production process is very high, and it is the highest production machine with highest accuracy can be achieved with a completely high quality surface can be achieved by this process. That's a Germany is one of the leading thing in electrical process. Where we are going to say tool and we have parts of electrolyte and there is a gap of about few microns, 10 20 microns, and through which this one passes and the gap. So this is a tool and the work is slightly double the gap length we can produce, and this has to be thing there. You see we have got the electrolyte and it will pressurize flow because it passes through a thin one, and the flow is in the order of Reynolds number 2000 to 3000 Reynolds number, very high flow. And then you can see it comes to a tank, electrolyte tank is there, then it is filtered because the reaction products add to filter and it passes through a heat exchanger. In the process, a lot of heat is and it has been brought down to a temperature and low temperature that to do it because we have to avoid boiling of this gas because Joule's heating will be much more higher here. You have to do. And similarly, based on this principle, we have developed a thing in IIT Kharagpur, a drilling machine where we conduct the thing and the fit control is completely control because it has to maintain a constant, but constant is very difficult to give because there is a small about the spark is that it has to be slightly withdrawn and then it has to move with the constant velocity. So we have the control system. Now to look at the process because time is short, so I am trying to show two videos. Now going back. Now this is a product, tripping tools. In one go, this is manufactured. So you see, very complicated parts can be machined very accurately, very accurately, and with all the good surface characters, without any side effects of the process is observed. Now, based on this one, then this is a thing we have tried to use the same technique on coating, because same thing, we have got a coating technique. This was developed in IIT Kharagpur. Okay, so in 90, and you can see we have got the tooling and all these things. We manufacture the cone, the cone required for in the what you call radars, small cone, and actually, in fact, we always try to do, while developing a machine, we find a component is not working all right, we develop another machine to develop that component. That means you have to see, while manufacturing, you have to see what are the bad things, how can we improve on that one, develop another system. That's why it gave rise to a lot of machines by the students and all these things. Generally, you can develop, and if you can start an industry, you can use them and develop this thing. In fact, this has gotten to manufacture, see, some of the thing that happened in Kharagpur, the paper, there is a, in paper, we have got some what you call watermarks are there. Generally, the depressions about 5 microns. Now, the stencils were imported, but the technology was given. The students started manufacturing that one, and they supplied to what you call the paper mills. Those are imported from Britain, and they manufacture in the country. Now, there is a big company started in Hyderabad making all these thin sheets of material as seams and all this thing. Now, this is a machine which we developed. Now, here we have to nose tip, smaller nose tips of any thing can be manufactured with this type of machine. And this peculiar thing, what I want to tell you, we are, the way is to give them as the project to the students. Okay. And finally, when they come out, they become themselves an entrepreneur, because I generally employ the second year students, because first year they get the basic training. Second year I choose one, because I go in a downward. I choose a project for the final year without anything and give that one to the second year students. I ask him, you find your next batch, lower batch, because generally in IT systems, it is that some people they tell against the ragging, but ragging in the real sense is good, because that senior student takes care of the boy, so that the whole ideas percolate not to the teachers, percolate to the in the downstream. But so I ask you choose two. So you similarly, each second year students, I ask them, you choose another two. So gradually they go on proceeding. If they don't like the project, they will back off from the second year, third year itself. Finally, you come to the final year. Now, when you finish out, then in course of the who stays from second year to third year, by that time the project is completed. So in the final year, the design, everything takes care. So the thesis project, what they do, they own the design. Somebody casually, they finally, the person comes to final year, they do this one. Similarly, I tried for the PhD students. You take two MTech students. Then I asked the same MTech students, you ask another final BTech students. You see, whole system for PhD, many people are ideas are mixed together, and in 3 years, they complete their PhDs and with a new machine. So that is the thing what I want to infuse onto this technology. We have developed this one. Then finally, we have done a thing. There is something which is called electrochemical grinding, which is a combination of conventional grinding and ECM. That is called ECD, electrochemical discharge grinding. Now, this is a project, it's old because in any of the factories, there is a, what you call, huge machines are in the junk because they don't give the accuracy. Now, here is a technique. The electrochemical processing is a better process which will reduce the force and productivity will increase. So I asked to convert this was a what you call PhD project, and let other students also involved with it. And finally, what you can see, the old machine is changed, what you call, with hydraulic drive, and we incorporate hydraulic drive because you have to give a smooth feed because surface feed is very high, and we give and backlash is not there, so we can use a grinding wheel, and the grinding wheel is nothing but it is a metallic wheel or diamond coated metal wheel, or you can take what you call conductive wheel, what you call conductive grinding wheel with the abrasive thing, and you can use the chemical and isolate this one to this one by changing the spindle. We completely isolated with from the bed and try to, and you see the bed is again isolated from this one. Otherwise, you see the chemical corrosion will start. So these are, everything has to be sealed and isolated, and you can apply the current to this one, voltage to both at the object and the this thing. We have got anodic dissolution by grinding process, and we have downloaded this machine, and this has been implemented in I don't know exactly whether in ABC bearings in what you call in Surat. Now, now electrical machine order, okay. Now, this is a machine which has been developed in high record by BTech students. You see, this is a micro, what you call, micro forming machine. We take a spindle and coat on that one. You can develop a micro, because in macro coating, it has to be pulse coating. Otherwise, passive essence will be too high. So this was developed by the thing. We've got so many controls are there. Finally, it has been modified to a single unit because this is a controller is there which constitutes all these parts, and the machine is there. We converted, retrofitted a thing and done this. So what you can see, this way you can develop systems, because now you can see I'm coming from individual machines to hybrid machines, where you can do multiple jobs depending on the requirement. Now, this is a thing. Now, the electro discharge thing, this is a very powerful technique which is used. Now, where we produce a discharge between a tool and the wall. These are minor, what you call, lightnings are created in between the two, and there is a direct medium in between, opposite to what you call chemical, there is electrolyte, and here we use a dielectric, and so the sparks can be produced, and this minute spark will erode the materials from the work, and the form of this one can be duplicated to this one. And this is called schematic of an EDM machine. Now let's see the process through, because this is a very complex process, and see. Now, the same process through a chart. Anyway, this is, I will skip this one. And then we have already seen this one. Now, this is a system what we developed initially when there was no EDM machine in the country. It was 70 times. This is the second model of the spark machine which was developed in Jadavpur University. And then we were the first to make a electronic pulse control thing, because this was thing we're using our Indian transistors. It is work with the same principle as switching device in computers. So what is used, with switching device, the power system was built, and it is successfully it works. And this is everything we have done. Basically, might have seen in educational institution, our main aim was that we don't have money to buy it. And if government funding cannot give, because these machines are very costly. And if you buy the imported machines, they are very costly. And second thing, they use a huge, what you call, jobs, job size to do it. So consumables, it's very difficult to process. So in an educational institution, you have to have a wide variation of variables so that you can experiment on the machine. So machine has to be smaller. So the cost of listening or experimentation is very low. That's why smaller machines are required. Now, this has come into vogue. That means everybody wants a smaller machine, because things are becoming smaller day by day, smaller and smaller. So the idea which we started in 72 or 70s, now it is being materialized now. So we started that long, because the thing is, you have to utilize your brain and walk somewhere and do something good, so that you can, as an engineer, you can go into the market and produce a thing and do the same thing. With that idea, we have started doing all these things. Now, where idiom you have seen, now I will show you this where idiom. This is a, you can see the whole spark comes in, because it is at a very high frequency. Sparks are there, and you can cut this one. The wire is to constantly fed, otherwise it will fail. Okay, surface can be a machine, and then you can see the other one. You see, with what accuracy, everything can be done with the thickness of wire, the thickness, even down to 10 microns, you can come down. Okay, wires are of 10 microns. You can have a beautiful thing here. You can see it's working very nice. So automatically you manufacture. That means this is a Viridium is a rapid prototype machine. You can, from one slab, you finish the product and finish in a Viridium. Okay. Now, only one thing, that is a thing you might have a question in your mind: how to put the wire. Generally we start from a thing, because the gap increases. You see, we start from the side, or make a small hole and pass to that one, or start from a bigger hole and go to that point and start listening. Okay. Now, similarly, what you can see here, you can have any configuration with the tool and the box. You can have grinding, everything can do with the EDM machine. Advantage is that one, because in the EDM process, you can, if you have seen that there is a something hardened layer, a white layer. Okay. Now you can do, we are doing it. That means you can machine it and make a coating of hard material, because that material we have seen that the white material they call it, because they use copper wire. Copper and you get alloys from that white layer contains some amount of steel, iron and copper. It is very hard. So something comes out as a positive sign, the positive sign, and that improves the surface quality. And if it is also, there is a bad effect also. If it is excessive energy, the crack is formed. So you can use a hybrid processing crack is formed. You polish that one with a what do you call same process. That is where you can combine chemical to the chemical instead of dielectric chemical and produce a discharge. Now this is the thing. Some companies they have imported because up till now we believe the white thing and we never believe our brown skin because of our mental setup. Mindset is not proper enough to accept our blackishness or something. We believe in white mindset. So that's why we import everybody, because in any import, everybody, people, that everybody gets what big share out of it. Now, anyway, I'm not going to criticize, but our duty is to how to improve ourselves. Now, machines are condemned. Lying outside in the sky, Bagdiwala, Kavadiwala, they are trying to take it out. Why not take that on and produce a die? Okay, it is worn out, it is oversized. If the gap is oversized, automatically you can replace this one, machine out. If it is more oversized, then you machine it out and use a replacement of the component. This type of factories have started in what you call in Andhra Pradesh, that is Vizag. But what's that? So there is so many things to start with. Okay, but we have to take the initiative and try to do it, and that has to be started by the young students, and then when they come to the final year, they become some idea of the technology and they can run the factory. Because we start a factory, two people they start, one with money, the other one with brain. So finally, when it settles down, the money people back out because I have to take the bigger chunk because that is the psychology. Now coming to, because time is running out, 6 weeks. Okay. Now this is a laser beam machine, and where we have either liquid laser, carbon dioxide laser, all these things. We produce a energetic vertical classes or discharges, whatever you say. We produce a conversion of any energy form to a light thing, and then especially in the infrared lasers are very good. We buy that one and then use a converging lens and focus that one on the target, and you can vaporize, and you have got any movement, then you can cut those things. And this is a pulse laser system what we developed in IIT Kharagpur. Now we built two laser systems. It is a CO2 system with Indian machines, Indian thing designed by in Ahmedabad, Cat Indoor, and they not in Ahmedabad, Cat Indoor, and it was manufactured by in Ghaziabad. I'm forgettable. Ghaziabad, and they started with a 100-watt laser system, and they supplied with a 20-watt laser system. We retrofitted this one, and finally we achieved 120 watt. From 20 watt to, initially we got 30 watt, and Professor Kel Chopra, he got a laser, same laser he repeated. He got 10 what do you call what thing. We improved that one to this thing. Then I took it. I was using that spares to run these systems and repair these systems. So this is CO2 system. You can see we have done. You see, cast iron. We can see here the hardness, RC value. We get 460, 490. It is leadimer in its form, and you can see we have hardened surface, and then you can you see the softer backing, because hard surface has to back by soft surface. the fatigue strength increases. Then you see the thing, the structure. And we could do it. If you see the conventionally, it takes about 48 hours to form dendritic on the surface. But here we see 15 millimeter per second speed, we produce what you call this thing, whatever high intense laser beam could do it. Now you can see we give a coating, and you can see we can form the alloy on the surface instead of, let's say, application. See, if you what is surface, and you have to make out of, let's say, this say for chemical industry, you want to go for stainless steel, costly. Why? Now you take any steel, soft and mild steel or anything, carbon steel, where the alloy can be formed. Now coat this surface with a little bit of any material which goes into the alloy. Okay, then we give intense beam. You can see we have got the flow of the thing. That's because the high temperature gradient, and we get the flow, and this is much more harder. It is a chemical. It is not alloy. It is a chemical vertical mixture at that temperature, and then you can see change the pulse size. You can see we have like a macro channel as well as heat rate, both the things. You see, you balance the heat input and the starboard control the energy level as well as the starboard speed, then the energy dump, and then you can do whatever. You can see silicon. Those are in try to deal with this one with KOH. It takes about to go to 1 micron. Takes about depth to 1 micron. It takes about 1 hour. Now we have gone with a pulse of 20 milliseconds. We pass the what you call hole through this one, same potassium sodium potassium hydroxide, and then irradiated with a 1.06 laser beam, and then we can drill it within 12 milliseconds. However, the surface is not good, but here what we have to do, we have to give a circular motion so that we can drill it much more accurately. But with testing, it is possible. Then we tried to, this was a problem when they wanted to small balls for the rotors. And then we said, okay, we try to make small balls. Ball making is a very complicated process. So what we do, we give a bomb, then you see it take the materials, powder into a ball shape, because when it melts, it's the minimum size it will take, it will become spherical, provided the friction force on all the thing is same. So droplet will be formed. That's why we took a powder material and the melt gave it a beam, and then it completely what you call spherical. Then we tried to join to the thing. Yes, it's possible. If we overlap two pulses, then it can be joined. Then finally, we manufacture a completely spherical ball. This is a high compressive strength, high compressive strength, as well as what you call porosity. You can use as a porous bearing or anything you can do. So now we see it can be used as a cladding, because surface, you take any material, clad a surface which not interact with the atmosphere or the places where it is being used. Now you can see this is a, see this, how this can be done. after after this one, we started. You see, in graduate courses, I've taken the students in IT Bhubaneswar. UG students, this is a new institute, we don't have the staff. And the UG students, they have developed the lab and they built the, what you call, this was in the old IT building, new IT system, we got a lab where the students have built the machines. Let's system, this is thing. This, we have not developed this thing. We have brought a concept. You develop the whatever the parts are there. You go for a design concept and assemble the parts. Because parts you buy similarly from the catalog, and then assemble them to this thing. Is on the basis of system design and all these things. Then build your own system, and you can do whatever you like. So the students, they run the laboratory and do this one by themselves. The machines are there, they have built it. Then no, so you see, the students can do themselves. These are the two people. Now, pathetic thing, we train the students, but they go to the management because of the money. This is the pathetic part of. But one, that means you should, once the students, you have to teach in such a way that mindset is not for what money. You the what you call Saraswati Kapasana. Well, anyway, so you can see it thing hybrid machine. It has been developed in IT Bhubaneswar. You see a milling machine and this thing. We are showing a cutting a ceramic with this one, and we can similarly we can do the heat treatment, everything, machine it and do simultaneously. Okay. Now how much time is there? I think 6:28. Now I'm asking the requesting the organizer, can I proceed with the I've got other things. Think it will take some time.
Yes, sir. You can continue, sir. There is no issue.
Eh?
Yes,
I'll
sir. You
show
can
this
continue, sir.
one because I'll show the video. It's about 15, 20 minutes video. It will set many other processes. Okay.
Yes,
Can I
sir.
go?
Yes, sir. Yes, sir.
have seen this one. We have seen this one. We have seen this thing. Now let's see. We have finished. Now it's-
Thank you, sir, for the nice presentation. And
Okay,
if
thank
some participant has any questions, they may ask to the sir, or they can raise hand. I will unmute them.
How can I see?
Sir, there will be a start video option in your screen at the bottom.
At the
Left,
bottom?
you can see. You have to click that thing.
This one?
At the bottom of your screen, at the left side, there will be a start video option. You have to click them. You have to first stop presenting your screen. There are some questions from some participants, sir. If you allow me, I ask on their behalf.
Which one?
Like, sir, one Mr. Ramesh Mane has asked one question. How
But
yes, sir.
can you see me?
Sir, you have to first of all stop presenting your screen. Only then your video will come.
Is it? Now? More record, disable thing. Hide video panel, hide video panel. Hide button. Share
Yes,
computer sound.
sharing your screen. You have to first stop sharing your screen and then you click the video presentation.
Video presentation.
Yes, sir. This will click up my video.
Mine is mute. No.
No, yes, sir. We are able to hear you.
Well, go, tell me the question.
The question is how we can maintain consistency of idiom finish on multiple jobs.
Can you repeat the question?
How we can maintain consistency of idiom finish on multiple jobs.
Consistency of
Idiom finish on multiple jobs.
on multiple jobs, it is say it can, because whenever you do it, you see it tapers out. Because once the wire enters there, spark starts, as it continuously moves or comes out down, the wire is tapered. Thereby, the hole is also tapered. So to maintain the consistency, you have to check the energy level. You have to check the energy level as well as what you call other cutting parameters. Because different machines, it is such a fictitious process. Can you hear me? No.
Yes, sir. Yes, sir.
It's such a fictitious process. It is unpredictable because it is a stochastic process. So you have to do experimentation, try to arrive at a solution to maintain the consistency. And consistency means at what tolerance level. So you have to vary the what you call speed of the wire. You have to vary the pollution rate of the dielectric. You have to also experiment on what you call the feed rate of the wire as well as the energy levels. You have to do the pulse width as well as the intensity. Because there is a sensitivity knob. In all the EDM machines, there is a sensitivity knob to have the feedback control. Okay.
And then there is another question, sir. In which machine photoresist processing is done and what are the photoresist materials?
Photoresist materials, you see, photoresist chemicals are available. These are chemicals are available. Generally, for mechanical engineering application, we make a stencil. Okay, apply this thing. There's so many. Depending the size, we take it thickness of the what you call coat. will give the accuracy in the job. Okay, and that is why cutting the stencils, there is a laser cutting, what you call machine with a thin beam. You can write on this one. So, but it has got a limitation that the focusing area has to be limited.
There is another question. What would be the precision of manufactured components? And in continuation with that, also does it would be able to handle any type of geometrical shapes and size?
You see, all the all the parametric combinations. You have to experiment out, because this is a in machine, physical machining, like what you call turning and all these things. You can measure everything and do it. But here, what happens? You have to first take a trial and make a data bank, and then try to find out what is the to achieve that one accuracy. Which is the suitable condition is to be set on the machine. This is possible not on the imported machines. In our machine, we can do it, because when you ask a company to import a machine, they will first ask you what material you want to cut. They will not give you the entire data bank, because they have to sell the machine. That is because that is why develop your own machine. Okay.
Yes. Sir, there is another question. What is the necessity of calibration before performing any machining pulse laser beam?
We always take a cut with some specific cut, and then try to take the sample and try to measure it. We do it.
Okay, sir. And then, sir, there is a question: why EDM process is forbidden in aerospace and defense industries?
Forbidden in
aerospace and defense industries.
Why? It is somebody is asking. EDM
Yes,
is not.
Someone has asked this question.
And it is a wrong concept. Wrong concept. I'll tell you one example. In EDM, I've shown a thing how the structural changes take place. We can give a coating. Now we are saying in EDM also we can do coating. You can also texture the surface. Texture the surface in the sense, you see, that is what is called surface modification. Another one thing I will try to tell you, you see, many people are criticizing the Chinese are using J-21. Do you know that is a dangerous aircraft? Because they have developed that system by taking the best parts of each, what you call, part for which is working the best. And they have assembled the parts. Okay.
Yes.
So it is much more rugged than anything. So that is why that is F-621, they're telling us we can, but it is very difficult. That the aircraft is a dangerous aircraft, because it is much more rugged than anything else. Anyway, I shouldn't discuss about that thing. That's the policy of.
Yes,
Anyway.
If any other participant want to ask question, they can just raise their hand. I will unmute them. I will allow them to talk.
Beg your pardon?
Sir, I am just asking the participants if they want to ask some question, they can raise their hand. I will allow them to talk. Or what you can do, you can send your questions to us, and we will mail it to sir. Whatever convenient way you feel, that is okay for us.
They can write to you or pass on to me, or you can directly ask them to write to me?
Yes, sir. They can send us to us, and then we will mail it to you.
That will be better.
Yes.
That will be better.
Yes, sir.
Because something you may be knowing also, you can answer back.
No, but they want to learn from the expert.
Now, you see, how we can share our knowledge. See, we have to You see, our thing is, हम लोग को नहीं आता है, पूछो मास्टर को क्या बोला. They will never try to think what is the answer. They will never try to read. There's so many things. You see, टीचर को पूछो, टीचर को थोड़ा ये अपना दिमाग से नहीं सोच सकते हो. No, that is a peculiarity. That is the mindset what we have been trained right from the beginning. मुझे खाना है, मैं चूज करके नहीं खाऊंगा. बस माँ की बाबा आके खाओ खाओ, ऐसे कैसे होगा? One should have a knack to learn all these things. No?
Yes, sir.
Who has? I have never. Nobody has taught me this thing. मैं जाके स्टूडेंट लोग, because I work with the students. Students को बोलता अरे every week I found okay तुम पढ़ो, मैं भी पढ़ूंगा. Student लोग we are providing what you call computers in each room. Okay, are they looking into study materials? Never. That is the mindset. A young aspect क्या था कि थोड़ा आसानी से ऐसे नंबर मिल जाएगा, डिग्री मिल जाएगा, चला जाएगा. ऐसे. In that way, I am a very bad teacher. Okay, I put the question anytime. मैंने कल देखो उसको उल्टा दे देता हूँ. उल्टा कैसे देता हूँ? तुम ये पूछा ना, तुम अपने को पूछो, तुम यही करोगे? Put the question back to them, or if you know, answer them. This is a simple thing you should have known. Actually, thing is, interactive studies नहीं होने पर nothing can be done. Nothing can be. When I was a hard taskmaster as a teacher, देखिए, I'm just frankly talking to you.
Yes, sir.
You say I don't have two eyes. These two eyes have been punctured by laser beam. मुझे glass नहीं था. So reflected laser beam make hole. So मैं जाके दोनों people को change किया. I don't have 5 bypasses हुआ है. Okay. And practically half of my part, but I don't have right knee. Okay. Left knee, what else? Everybody told you replace the knee. Now I reverse back. I am now, people, Professor Ghosh saw me about 3 years back. He told, Array, you are holding a stick. No, I reverse my whole entire body unless you try yourself. Change the mindset. Okay. Yes, correct. Verily, they want students, if they want that, okay, teacher will sit with me and answer my question. It's a high problem. And high people. Some of the teachers, what they become the coaching. So anyway, that's also, unless we have a mental set of nations conference, nothing can be done. Any question? Anyway.
No, sir. Thank you. So thank you very much, sir, for your presentation. And it was a very nice presentation, and thank you on behalf of all the participants that you have given your valuable time to us. We are able to learn from you, from your experience. You have developed so many in-house machines, so many processes, and it was a very nice and informative session. The way you have explained using videos and the slides, that clear many of the doubts most of us are having. And with this, I thank you for presenting such a nice and beautiful session. Thank you very much.
Okay, thank you. Thank you. Namaskar.
to the participants, tomorrow we have another session that will start from 10:30, and the first session is on thermal issues in advanced manufacturing, and this lecture will be delivered by Professor Pradeep Datta from ISC Bangalore. And after that, at 3 p.m. we are having lecture from Dr. Debashish Bhattacharya, Tata Steel Limited, and he will be delivering lecture on material challenges for advanced manufacturing. And at 5 p.m. we have lecture on the industrial internet of things from Mr. Rahul Sagar. He is in Design Tech System Private Limited, Bangalore. So I hope to see you all there. And from here it is an end for today's session. And enjoy your life. Take care. Thank you.
So one thing I want to ask you.
Yes, sir.
Can I attend that one?
Yes, sir. Yes, sir. You can.
Because
we have already sent you an invitation.
Okay.
As a panelist, you can attend all the sessions, sir.
Okay.
Thank
because
you.
some sessions, because I want to, Pradeep Datta, my student.
Yes, sir.
Okay. So I want to hear him. Okay.
Okay. Thank you very much, sir.
Okay.